Hi, this is Ajay Nair, and I'm going to explain Fick's principle. So let's start with what we know about Fick's principle. We know that if we're given VO2 and if we're given Ca, which is the concentration of oxygen in our arteries, and if we're given Cv, the concentration of oxygen in our veins, we can use this equation, Fick's equation, to get cardiac output. But what does this even mean? In order to understand this, we need to understand what VO2 is. What is VO2? VO2 is the amount of oxygen that is being used by all of the tissues in your body. And we can write that out as the amount of oxygen that goes into your body's tissues minus the amount of oxygen that comes out of your body tissues. Obviously, if the oxygen has gone into your tissues and it hasn't come out, then it's been used by your body's tissues. And that's what VO2 is. It's the amount of oxygen that is used by all of your body's tissues combined. Now, we can't really measure this in one specific moment in time. I can't say like right now how much is my body's tissues using, how much oxygen. So we use this as a rate. We say per unit time, or usually per minute. So we should change this equation by writing it like this. VO2 is the amount of oxygen coming into your tissues every minute minus the amount of oxygen coming out of your tissues every minute. Now, how do we quantify this oxygen? How do we measure it? Usually in physiology, the units we use are milliliters. So we'll rewrite the equation once more to say that VO2 is the number of milliliters of oxygen going into your tissue every minute minus the number of milliliters of oxygen coming out of your tissue every minute. All right, great. So how do we take this and get it to be Fick's principle? Well, there's one idea that we have to address, and that is our oxygen is getting to our tissue and coming out of our tissue through the blood. So if we want to know the amount of oxygen coming into or going out of the tissue per minute, we need to know two things. Number one, we need to know how much oxygen is in every liter of blood. How much oxygen is in every bit of blood? And how much blood is going through the tissue, since our oxygen is dissolved in blood. So the two things we need to know, how many liters of blood are going through the tissue per minute, and how many milliliters of oxygen are in 1 liter of blood. Here it is written out. So as you can see, what this says is the amount of oxygen per minute equals the amount of oxygen per liter of blood times the number of liters of blood per minute. And this should make sense. Let's do an example just to clear it up a little more. So let's say that I had 5 liters of blood going through the tissue every minute. So if you look on the right side, we have liters of blood per minute. I'm going to swap that and put in a 5. So if I have 5 liters of blood going through my tissue every minute, now let's say every single one of those liters of blood had 100 milliliters of oxygen. Okay? So now I'm going to take that middle term and put in 100. So every single liter of blood had 100 milliliters of oxygen. So then it makes sense that if I have 5 liters of blood going in per minute, and I have 100 milliliters of oxygen in every liter of blood, then I would have 500 milliliters of oxygen going through my tissues every minute. So this is how we figure out how much oxygen is going through per minute. We need to know how many liters of blood are going through per minute, and we need to know how many milliliters of oxygen are in every liter of blood. All right, so how does this idea that we've just fleshed out, how does this apply to what we were talking about before with VO2? Well, we can add this concept into our VO2 equation. So on top, we have the equation we had before. The simple idea, VO2 is the milliliters of oxygen going into your tissue per minute minus the milliliters of oxygen coming out of your tissue per minute. And now, what did we say? We said that milliliters of oxygen per minute can be rewritten as milliliters of oxygen per liter of blood times liters of blood per minute. And so here is the new form of our equation. Now, when you look at this equation, I want to direct your attention to the term liters of blood per minute. What is that saying? So we're talking about the number of liters of blood that are going into all of your tissues every minute. Now, it should make sense that that would be the exact same number as the number of liters of blood that's coming out of all of your tissues per minute. All the blood that goes into your tissues has to come back out of your tissue. And in fact, since the circulatory system is a closed loop, all of that blood is going into the heart and it's coming back out of the heart. And it's being pumped by the heart. And what is our term for the number of liters of blood being pumped by the heart per minute? It's cardiac output. So the liters of blood per minute can be rewritten as cardiac output. So that makes our equation look like this. VO2 is our milliliters of O2 per liter of blood times cardiac output in minus milliliters of O2 per liter of blood times cardiac output out. Now, let's look at our other term now. Milliliters of O2 per liter. This is another way of saying the concentration of O2 in the blood, right? We're talking about milliliters of O2 per liter of blood. That's concentration of O2 in the blood. Well, what's the concentration of O2 in blood that's coming into tissues? What vessels are going into tissues? Arteries. So this is our oxygen concentration in arteries. And what about on the second part of the equation? Concentration of O2 in blood going out of the tissues. Well, those are veins. So that's our concentration of O2 in veins. So we can rewrite this again as this equation. VO2 is Ca times cardiac output minus Cv times cardiac output. Now this should start looking familiar to you. Oh yeah, well, with a little bit of rearrangement, we actually have Fick's principle. So let's do that rearrangement really quickly. So when you have two terms here that are both being multiplied by the cardiac output, we can factor out the cardiac output. And so we get this. VO2 is cardiac output times Ca minus Cv. And now we can take the term Ca minus Cv and we can divide both sides by that term. So let's do that. We divide both sides by that term. What do we get? We get Fick's principle. VO2 divided by Ca minus Cv equals cardiac output. That is how Fick's principle is derived.